In this next video, what we want to look at is how we go about doing graphs in this class. A lot of the data that we're going to collect in the labs that we're going to do during this course, we're going to end up graphing to get a look at the relationships that are involved and to better understand the data that we have collected. There's some certain basic rules we want to follow when graphing. All of the rules that we're going to go over in this video are found in the Graphing Rules document that is available on Edline. One other thing that I would ask is that you please print out a copy of the GLX Introductory Lab and bring it to class tomorrow. That lab will be starting in class tomorrow, and having a copy of it would be very helpful for making the lab much more efficient. Now, when doing a graph, there are a couple of things that I want you to follow. I mean, there's 10 basic points, and I want to go through each of those. And then I want to look at a bunch of example graphs and show you some of the things that I think could be done better. When we're doing a graph, we want to use a full piece of graph paper. I will provide graph paper in the classroom. I'll show you in class tomorrow exactly where that graph paper is located, and I will always have graph paper, so you should always use a full piece of graph paper when doing a graph. Don't try to save paper with the graphs. Don't try to make them really small. Make sure that you use a full piece of paper. At each table there's a ruler, so use those rulers when doing graphing. Each axis should be drawn with a straight edge. Make sure that you plan ahead when doing a graph. Note the largest number that you need to put on the graph and plot the axes so that your scale is large enough that it takes up at least 2/3 of the page in both the horizontal and vertical direction. Don't get your graph so it's only down in one little corner of the page. Make it fill up the whole page that you're using. So you should make sure your scale covers at least 2/3 of each the horizontal and vertical axis. Once you've created your axes, make sure to label the axes and put the units in parentheses. So you should always see a label such as distance and then a units such as centimeters on each axis. Yeah, all graphs should have a title. A good title that always works is y as a function of x. You could also have an independent variable is usually going to be plotted on the horizontal x-axis. So if your x-axis was time and your y-axis was distance, you could do distance as a function of time. Most graphs should start at the origin, 0, 0. There are exceptions, like when you graph temperature. 0 has no special meaning in temperature, 0 Celsius. So the origin does not have to be 0, 0 for temperature, but for most of the graphs we're going to do in this class, you should be starting with an origin of 0, 0. Pick a logical scale and stick with that scale. 0.1s, 1s, 2s, 5s, 10s, 0.01s, whatever it happens to be, stay consistent. Try not to pick an illogical scale like 3, 5, 7, or it's hard to follow. One thing that's good is to put a small circle around each data point, lightly in pencil. This will help show the uncertainty of your data, and if you're doing your graphs in Excel, that will be done for you if you put that setting in. Look at all your points. Draw a best straight line or curve that goes through as many points as possible. Most things we're going to be dealing with are straight lines, so you want to draw a best fit line that connects that goes near as many points as possible. We don't want to play connect the dots. We want to make sure our line goes near as many points as possible. We very rarely, if ever, use point-to-point connections. If you plot 2 or more lines on a graph, make sure that there's a key on the right-hand side, and please use 2 different colors of ink when doing that. And graphs not meeting these basic requirements will be returned to you to be redone. I will not accept these graphs and just mark off. I will ask that you redo them if they do not have these basic properties. Let's look at some example graphs and see cases where it doesn't make a whole lot of sense. Here we have a graph. You can see the scale on the left-hand side, 0 through 12. All the points are from 8 through 12, and there's no way to tell any difference really between those. It would have been much better to use a much smaller scale, not 0 to 4 to 8 to 12, but maybe 0 to 0.5 to 1 to 2, to spread out those points and being able to see them. Okay, when looking at this graph, there are a couple of things to point out. The scale is pretty consistent. It's kind of hard to see here, but they actually have 0.01 right at this point, so using 2.5 blocks for 0.01, which is fine. This line shouldn't be here that I drew. This scale is consistent, 20 to 40, 60, 80, so we're going up by 20s for every set of blocks. One thing you mistake I see here is in this best fit line. This best fit line, you'll notice in this section is curved, and then it's straight in other sections. It looks like someone tried to curve the line to make it fit as well as possible. This case, this graph has some serious issues. Most glaring issue in this case is the fact that there's basically connect the dots and not a best fit line. This graph, nice best fit line, nice scale. Would have been better to start at 0 for the vertical scale. You can't see any of the points. You can see the best fit line, but the points are so minute you don't even notice them. Here, well-drawn points, nice best fit line, makes it very linear. Let's look at the scales. 0.2, 0.3, 0.4, 0.5, that's very consistent, 2.5 blocks each. Look at this, 29 to 38 to 54 to 62. Not a very consistent scale. This one goes up by 9, this one goes up by 6, this one goes up by 8, this one goes up by 14, this one goes up by 8. So not a very, and the bottom one goes up from 0 to 29. So not a consistent scale, which leads us to read a graph that we can't really see. This case used hardly any of the paper. You notice the whole graph is down here in this corner. You need your scale to cover at least 2/3 of both the horizontal and vertical axis. Spread your graphs out more than this case. So there's some basic examples and the basic rules of graphing that you want to follow when doing your lab tomorrow and all future labs in this course. When doing a lab, please make sure to bring a copy of the lab with you. So make sure to print a copy of the GLX introductory activity from Edline tonight so that you can do it in class tomorrow.